Again, you have four LO for these 20 marks. So LO1, LO2 will be your S1, LO3, LO4 will be F2. Final exam will be 4 LO. So each one will come up with one question. Part LO4, you will see two questions. This one is L1. L1, L2. Then LO3, LO4, that's good. And final will be all 5 questions, compulsory 3. Then question 4, question 5, choose one. Okay, so we are now still at particles. Once you complete particles, you go into rigid body, just a little bit modification of what you learned previously. Then you will solve a lot of tutorial questions. Okay. Chapter 2 is a continuous of what you learned in your statics. And you will only use one equation where you're very familiar. It's called equation of motion. F equal to ma. You will repeat many times this equation for chapter 2. F equal to ma. We need the second Newton equation. You know Newton have Newton first law, second law, third law. We are looking at second law. So same second law, we will look at rectangular motion, or sorry, rectangular coordinate with x, y, z, and tangent normal with circular motion. Right? Same. It's just that now you have one more diagram. We'll go into one more diagram, one more definition for chapter 2. It's called kinetic. Kinetic, you observe what happened to the motion under the action of force. So in previously your static module, you ask you to draw free body diagram, right? Here, when you reach chapter 2, you need to draw one more diagram by the side. It's called kinetic diagram or kinematic diagram. And in your solution, you always break your solution into half. On the left-hand side, always deal with all the force. On the right-hand side, you always deal with motion only. Here is what you learn in your statics, and all the force, moment on the left-hand side. But when you come to kinetic chapter 2, you deal with acceleration, velocity, two components here. And when you deal with mass, we live in the Earth. Earth, we have something called gravity. Gravity will always pull you with gravity. When you have mass, you will get something called weight. Weight is fall under free body diagram and not this side. So don't mix the wrong one. So, and here you start to look at gravitational force, will give you weight. And you need to recall what is friction. What is friction? Let's say this is an object always mass. Every time you draw free body diagram from chapter 2 onwards, you will always consider W equal to mg, and you are acting by a force, let's say force to the right. Because you will have your axis system, x, y, right? How to find, if you are given mu friction equal to something, right? How do you find the friction force? Friction force always opposite of the motion. So you always opposite, and we'll use Fs or F friction. F friction, what is the equation? You still remember? Mu
mg.
Huh?
Ms.
N. What is N? Normal force. Remember, you have one more normal force here. And when normal force come into place, when the object have contact on all the surfaces. Okay? When your object have contact, so what happens if you don't have contact? Example, you shoot a bullet into the air. You still have contact, but it's not, you don't have N, but you have something called drag or friction, air friction. You become FD. Okay? So this is what you need to recall back. Be careful on the left-hand side of the diagram, free body diagram. Normally you will miss the normal force. With 99% you'll be there. But most of the time you will be blocked, you will be confused how to find your friction force. And the normal force always 90 degrees to the body. You have a slanted, your normal force always follow the surface. So introduce you back F equal to ma. We are still dealing with vector. Only one inside the equation is not vector, which is the mass. Mass is not a vector, it's a scalar numbers. It's a constant variable. Force is a vector, vector has magnitude and direction, same with acceleration. We call it equation of motion. So in the question, we won't mention equation of motion. We'll give you here something like use your understanding in Newton's second law of motion. Analyze something. Then you know this is from chapter 2. Okay. So since you are taking civil and mechanical, you will see this equation. This is on the gravitational attraction, also apply to second Newton law. Just an introduction. We want to test this equation. If you have two bodies orbiting in a vacuum, the only force pulling each other is a gravitational force between each other. So you use this equation F equal to G M1 M2 divided by R2. What is G is a universal constant, 66 point something. R is the radius between these two, right? So this is just an introduction to you guys. If you want to apply this. So I'll speak briefly. If you're interested, you can go and read the slides. Then we come to F equal to ma. We start dealing with force in this chapter. So let's say there's a particle subject to two forces. From these two forces are vector. You can combine the two forces become resultant. Okay. So recall how to draw the vector diagram. Then we go to another side of the solution, which is the motion or kinetic motion or kinetic component, which is ma. The force will convert into mass and acceleration. The red arrow here is acceleration, not forces. So chapter 2 deal with the effect of force to the motion. Motion here referring to velocity, acceleration, and position. Okay. So this is diagram that we expect from you. On the left-hand side, you always draw free body diagram. On the right-hand side, you do kinetic or kinematic diagrams. As you learn further and further, you will be overlapping the left-hand side and right side. You'll pull this one inside here. Because you have no time to redraw the object of this. Just take a second. But for the beginning, the test 1 and test 2, you need to split the two documents. Okay? All right. We are dealing with sum of the force. Sum of the force. And if you deal with direction, you can split the equation into okay. In this diagram, you have different particles, different individual particles. So let's say you pick one particles and you have a force acting on it. You have a force and big force and small force and so on. Then you will form kinetic diagram with this MA. So I means individual response. So again, this is just to show you that you need to add all the force together to find the acceleration. All right, skip I, delete that. Just a derivation of the equation. In your static, you learn how to find center of mass. Later, for particle, we don't need to find center of mass. But when you go into rigid body, then this equation will come into place. Right? Later, we will look into this equation. For chapter 2, okay, then you in 3D, then you can break your vector into I, J, and K. This is a recap of what we learned. Your force on the left-hand side, you can break into I, J, K. Your kinematics parameter also can break into I, J, K. Then you compare side by side, x to x, y to y, z to z. You solve one direction, one direction, one direction. Don't mix with them. Okay, there's an equation for force in the x direction, same with y, same with z. Like what you see in the previous example before we go into the second. We apply what we learned. Look at this diagram. You have a crane with 50 kilograms, pulling at 30 degrees with the force of 400. You are given friction force, not friction force, friction coefficient. You know that when you're given friction coefficient and there's a contact between the floor, you are expected to find the friction force. Subject to a 400 Newton towing force and so on. Determine velocity at 3 seconds. The step still the same. Break your solution or your answer sheet into half. Left hand side free body diagram. You need to write free body diagram and kinetic diagram on the solution. If not, I don't understand what we are trying to do. All right, write this free body diagram, kinetic diagram. Then draw a line in the center. On the left is revolving all the forces on it. What forces you need to add in? This is called the free body diagram. Normal force and then friction force and weight. This one automatic will come up on every time you draw free body diagram. Normal, weight, friction. When there's a contact, there's a contact. And sometimes the question will purposely tell you the surface is very smooth. Very smooth means you don't have friction. Okay. Equal kinematics is the motion, where is your acceleration. When you draw, based on this diagram, you predict the motion. You draw the motion to the right. Okay. Then the rest is just solving simultaneous equation or linear equation. Pour out second Newton law, F equal to ma. You write F equal to ma, and then you break into x direction and y direction. You know that force can break into x direction, y direction. Your x direction, force P here will become 400 force per P. Friction, go against x direction. Friction force will become negative. This one, y direction, y direction. Be careful on the negative side. So the first equation you have will get this one with the negative sign for friction. Normally, the mistakes will be the negative sign. You'll forget. In your free body diagram, you give correct, but when it comes to your analysis, you will get, I don't know, somehow some student will not positive for the friction. Just be careful on this. Why also say your P force here can break into Y direction, which is 400 sin 30. Friction doesn't link with Y direction. Weight go down, negative. Normal force, positive. Here, mistake normally you'll mix up the normal force. Remember, always exclude normal force when there's a contact surface. Okay. Remember, this one normally, when you panic, you will forget. So you have two equations. One with NC, one is A. Second equation, you only have NC. So we solve equation. First one, you solve for the NC. The second one, once you solve NC, substitute that, you get T. Make sense? Okay. I'll give you the answer. And we're equal to 200 something, 290 Newton. Important unit now. Newton. A is meter per second square, 5 point something. In your answer, give the minimum 2 decimal place, maximum 3 decimal. Okay, so it asks you to find velocity, 3 seconds. You have acceleration here. How to find velocity? We are pulling at the constant speed, constant force. Your speed will be, your velocity will be constant. Right? Sorry, your acceleration will be constant, where we have a constant force pulling at the vector. So you can call out the 3 equations that you derived in chapter 1. V equals something, then the S equal to something, E square equal to something. That 3 equations. We apply this one because we are given the time here and the initial velocity we are given, because we tell you we start from the rest. So this equation VO here is 0, VT is given, AC you'll find just now. So you're able to find velocity after 2 seconds. Substitute T inside the equation to get the V. And remember to tell the direction. Chapter 2 onwards, remember to have a habit of drawing arrows behind your answer. Either up, down, or angle. Okay. So yeah.
So it's just right. Like right.
To the right.
Okay, to the right.
Okay. Or you can go to your diagram there, here. Just add in one more arrow here. Okay. Second one. First example have contact surface. Second one don't have contact surface, but in contact with air and molecule. So it gives you the mass of the object. You launch a cannonball, vertical upwards, and initial velocity 50. So ask yourself, are you able to draw free body diagram given by these states? And you're given Z reference from the mouth of the gun here and Z. With the initial velocity, you're given initial velocity, one number, 50 there. Determine maximum height. We have 2 scenarios. One, ignore atmospheric resistance with no friction. Second one, with friction, you're given friction force, one equation, 0.1 V squared. This is a engine dynamic question. And you won't see this one in statics. So static dynamic, you deal with a lot of equation. Lots of unknown parameter. Where V is a speed of projectile at any instant V. Ask yourself, are you able to draw free body diagram for the first case? How to draw free body diagram for the first case? Draw a dot. And what else? First thing, always deal with your gravity. Always remember there is a W there. Then you look at the diagram, what else? Do you have force? There's no engine there, no? Just a free motion go up. There's no force pulling it up. Just launch into the air. There's no pulling force. The only thing that makes the cannonball go up is the initial force. It's the initial momentum inside them. Okay, then MA, same. What is the motion? Motion, go up. And okay, then you solve for equation. F is equal to F. Free body diagram. Again, break into half. Free body diagram, one side, kinematic, one side, kinetic, one side. Draw diagram, mg go down. For the first case, we ignore resistance, so no resistance, no force. Kinematics go up everything. Then you solve, determine maximum height. So maximum height, how you find? You know that this is constant acceleration. So we call the tree equation. Then find the either one of the equation determines. Okay, so equation of motion, then we go to MA. This one will tell you minus mg because go down, minus positive MA. Be careful on the negative one. Normally you will subconsciously you write positive. Okay. At this stage you can cancel m because it's the same, but you can still substitute if you want. Right? Mass given here is 10, so you substitute that. Or you don't need to substitute because cancel. Right? So your acceleration equal to negative 9.81, which is your gravitational force. But it's negative. Why negative? Go up is positive, but acceleration go down. Okay. So you have your A, then go to your kinematics diagram. Kinematics, there is one equation, so it deal with the position. So V square equal to V naught square plus 2AC, the change of position. You know your final velocity, right? What is the velocity at the highest point? 0. Although it's not mentioned here, but logic you should know. Maximum 0. Initial velocity was given 50. Acceleration was fine just now. Z, you want to find Z minus Z0, reference 0. So this one 0. There's only one unknown, you can find yourself. Okay. Then second part. Second part, demonstrate resistance come into place. So you go back to your free body diagram. The motion go up, resistance always against the motion. So force is going down. Huh? Okay, FD is on the object. And we always draw our force, go through the center point of the object. Huh? So we move this one to center point of the object. Huh? Then the same for MA. Again, left-hand side free body diagram, right side kinematics of kinetics diagram. The rest, you apply the F equal to MA direction. That in this case. All right. So carefully look at the diagram. The diagram give you Z. In your answer, don't give Y. If you write Fy equal to My, I will put question mark. Where is Y? The question gives you Z. You write Y. And in your diagram here, there's no X, Y, Z, so I don't know what you mean. I put question mark. Okay. It's just a notation. Then your FD was given in the formula 0.01 V2 V squared minus mg equal to ma. To find velocity. So you substitute value for mass, gravitational force, mass. You get your acceleration in the theta. So recall there's one more equation beside the tree when we freeze the time by using velocity equation. We freeze the time, dt equal to dt. You arrive at a dx equal to v dv. So use this equation, when we freeze the time, we can relate acceleration and velocity. You put in the acceleration equation just now, minus something, dz, v dv. You see dv one side, dv one side, or d something. The next one is integration. To do integration, you need boundary condition. What I mean by boundary condition means integration, you have lower limit, upper limit. So you have a boundary condition there. You have v and z. So you have two boundary conditions. When your z is 0, your velocity is 50. You start with 50. What happens if your z equal to z? Z equal to z, velocity is 0. At the maximum point, velocity is 0. Okay. Then you do integration as. Here, move the same v to one side because this is v. V cannot be z. Cannot integrate with z, you get 0. Not 0. You will have v term on the left hand side. Move your v to the v side. So you have 1 over something. The dz one side, dv one side. Okay. Do integration. Put in the limit z 0 to z for maximum height, 50 to 0. So not normally, previous tutorial question, you always start with rest, but this one you start with 50 to 0%. Right? So you do derivation, it's your homework, huh? You get z equal to 1.4. Yeah, here you do homework, huh? You do derivation, you get your z equal to 1.4. This one you very familiar. We learned that one 20 minutes ago. So you are given a pulley system. You see pulley system, first step, look at the datum. Second, calculate the length of the rope. Differentiate the rope, the length of the rope, you get velocity. Differentiate one time, you get acceleration. That is the step every time you see pulley question. Do that one part first, then go and look at the question. 100 kilogram block A, release from rest, so you have your initial velocity, it is 0. If the mass of pulley and the cord is ignored, determine velocity of 20 kilogram block B after 2 seconds, we release is. So A is 100, B is 20. You release A, what happens to B? Go up, huh? Okay, so here we draw free body diagram first. We need to determine our focus is B, but remember when it comes to chapter 2, we deal with F equal to MA. You need to see your diagram having force inside the diagram. We are dealing with force in chapter 2. F equal to MA. So from this diagram, what are the forces? Tension of the rope. Tension of the rope and the mass of the object A and E will become W. Okay, remember, huh? So this one is a combination of previous chapter 1, the last part, and chapter 2, first part. It's a combination question. Okay, so you solve for tension first. So this one you have two tension, right? Look at pulley C, which C. There are 3 ropes on the C, so this is your static question. So we have 2 tension and 2 tension on the top and 2T at the bottom. Right? This T and this rope represent the summation of these 2 tension. Then you go to mass A. You draw free body diagram for mass A. Mass A will have gravitational force on it. So you always have W, which is your mg. And the rope on top of it is 2T, 2 tension. So the tension of A will be different from tension of B. Because of the number of pulleys. So for object A, you have 2 tension, 2T, 2 tension force. So this one we solve for the force first. We convert all the diagram we have here into force. We solve the force first. Okay, equal to MA. You know that A is so here also we follow the datum direction. Datum direction go down. Although we know that sometimes A can go up, but we follow the datum. Datum point down, SA point down positive. So our kinetic diagram or kinematic diagram, our MA is pointing down. Okay. So this is how we solve for pulley system. And once you get some at the end, sometimes you get negative A, means that the opposite from the datum. You solve for A, then you go for B, yeah. So this one you go to datum A, then go for B. For mass B link with only one T here. This is T. So this T tension will follow used by B. So the B will be only single T and not 2T. And the weight is mg. So same, force equal to MA. Force already done. MA also following datum. MA point down, datum go down. Okay. So far we're following the datum so far. Although yes, you know that you let go of A, B will go up, but at the moment all our diagram we're following the datum. So you have F equal to MA one set for F equal to MA for B. Then there are some parameters missing. You don't know what is the relationship between A and B. You use back the total length of the rope to find between A and B. So we look at A first. A, F equal to MA. You analyze all the F here. Go up, go down positive. In this case, we follow the datum, not the normal go up positive. We follow the datum, go down positive. That's why your mg is positive and not negative. Minus T, MA. You get the first equation. You substituting, you know the mass of A, you know the gravitation force. You get the first equation with T and acceleration of A. You repeat the same for B. You repeat the same for B, you get one more equation that link T and AB. So you know, this is B. You go to your free body diagram and kinetic diagram, F equal to MA. We solve all the force again. The positive direction for object B go down positive. Don't assume always positive. When you see pulley system, refer to datum. So you see, mg now is positive because datum point down positive. Right? With substitute value, you get one more equation that link T and AB. We have two equations. How you find A and B? We think back the final section of chapter 1. Find the total length of the rope. Differentiate, you get A. You get A and B relationship. So this is what you learned previously. Total length equal to this one plus this one plus this one. So we have 2SA plus SB. Get this equation. You know that total length doesn't change after you integrate with time. So 0. This one SA become B, SB become B. You rewrite. You get 2A equal to minus B. You have this relationship. You have one equation, two equation, three equation, three unknown, you can solve. Substitute this one either of it, then solve simultaneous. You will solve either A or B first, then you will find B. Substitute back inside here, you will find the C. Sense? The rest is mathematics. Doesn't really need okay, I'll give you the reference answer. T equals to something, A equals something. Okay, then you will find that velocity at block B at 2 seconds, and then A and B, they are constant. So when they are constant, you can use back the free motion equation. Depends on what you need to find. So here, I use the first one because I given time and initial velocity was given. Initial velocity from rest. Okay. So from rest, 0, AB, you already find just now. Time 2 seconds, you can find the velocity of B after 2 seconds. Negative, what does it mean? What? Cause your datum positive go down. This negative will tell you the direction of the object. Okay, so don't confuse with the positive negative direction. That is very important. Okay. Okay, I think we can here.